Okay, so the third in a series of 3 videos that cover all of the review worksheet. Again, we did number 1 yesterday in each class, so today we're doing like a third of the rest of them. It's not quite every third one because the free response questions are split up weirdly, and so to make sure we hit 1 free response in each class, I kind of divvied them up a little bit weird. So this class will do 4, 7, 11, 14 on the video, and then I'll be happy to do any others that you have questions about after that. Number 4, find the particular solution. So that means separate, integrate, and use the initial condition. There's been years where students want to come up with that third step and make it rhyme. Separate, integrate, and then, I don't know, something that ends with 8 that means plug in the initial value. What's that? Phosphate. Usually they go with something like algebraificate or something like that. Plug-inificate, whatever. Separate, integrate, and then use that initial condition. But again, use the point isn't as fun as making it rhyme. So let's separate and integrate, and then we'll use that point. dy over y equals secant squared x dx. Antiderivative both sides. Left side. It's supposed to be easy. We've done the left side quite a few times by now. By the way, everybody's on the draw side now, so we can pick on some people. So Isabella, right out of the gate here, what's the antiderivative of dy over y? Good, natural log of y. We do need to be a little bit careful. Officially, it's supposed to be absolute value of y. Like 99% of the time, that doesn't matter. It ends up being positive, and we don't care. But just we should be careful and put the absolute value. Braden, even if you weren't sure, you could look at your answer choices and probably figure out what's the antiderivative of secant squared. Plus c, yes. And again, even if you weren't sure exactly which trig function it was, like look at your answer choices, they're all tangent, so that maybe makes sense. Okay, now we start the algebra dance. E to the other side. So e to the tangent of x plus c, which is kind of weird. But there's one more algebra step to this little dance, and that is move that c down front. So y equals c e to the tangent of x. Now, I look at my answer choices, and there's only one that matches that, and so it's got to be c even before I plug in 0, 5. So officially, I should plug in 5 and see what I get, and I get c equals 5, so that confirms it. But again, answer choice C was the only one that fit the right format even. Okay, a lot of this going on the left. Antiderivative of dy over y. That's natural log. That happens quite a bit. The right-hand side, that's where we get creative and stick all sorts of things to test your derivative and antiderivative knowledge. Number 7. Oh, we hit this one yesterday. P of t is the size of a population. Which of the following differential equations describes linear growth? Okay, linear growth. I know what linear growth looks like. What does linear growth mean in terms of slope? Constant slope. Well, constant slope means my derivative is constant, so it's got to be a. But man, that one throws people off. They don't ever pick the squared stuff because they don't think that's linear. It's not linear. They're thinking linear is 200t or 200p, and in some sense, yes, that's linear, but that's a linear derivative, not a linear graph, or linear slope. Number 11. Here's your one free response question. Even tell you this was in 2019. This was number 4.
Is it a 2-day test or just all Monday?
It's a 2-day test. Monday is no calculator. Tuesday is with calculator. Cylindrical barrel with diameter of 2 feet. I need to be careful. That means R is 1. So, as shown in the figure, the water drains out through a valve at the bottom of the barrel. So, like water dripping out. The rate of change of the height of the water is modeled by, they even gave us the equation, dH dt equals negative 1/10 square root of h, where h is measured in feet and t is measured in seconds. The volume is V equals pi r squared h. Find the rate of change of the volume of the water with respect to time. So this is one where we got to be thinking about what's on the left-hand side as well as what's on the right-hand side. So dV dt, when the height of the water is 4 feet, indicate units of measure. You know what? I can do units of measure right now. The units will be volume over time. So if we're in feet, that'll be feet cubed per second. And truly, that was probably worth 1 point on this multiple choice, or on this free response question. And so even if you didn't know anything else, you can figure out the units of change in volume over change in time. That's a free point. dV dt, and all I know is that V is equal to pi r squared h. Okay. But R isn't changing, so that's nice. I can just plug in R equals 1. Because as the volume changes, R doesn't change. So that means I can plug in R for this equation, or for this situation. R is a constant. R is 1. So dV dt is equal to pi times dH dt. Okay, but I don't know dH dt. Oh, I sort of know dH dt. dH dt is negative 1/10 square root of h. So if h is 4, dH dt when h is 4 would be 2/10, negative 2/10. So negative 1/5. And then I can use that. So dV dt is pi times negative 1/5 feet cubed per second. Okay, so that's like old stuff. That's not what we've been doing recently. Part B, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to t increasing or decreasing? Is dH dt increasing or decreasing? How do I figure out if dH dt is increasing or decreasing? That's a tricky question. How do I usually figure out if something's increasing or decreasing? Okay, so you're thinking velocity acceleration, but more generally the derivative. If the derivative is positive, then whatever we're talking about is increasing. So I need to know the derivative of dH dt. That will tell me if dH dt is increasing or decreasing. So they're sneaking an extra derivative in here. So I need to take the derivative of dH dt. So the derivative of dH dt, alright, I'm going to rewrite what dH dt is, and I'm not going to use the root thing. I'd rather write it as a power. Okay, so the second derivative then is going to be 1/2 times negative 1/10 times h to the negative 1/2 times dH dt. That's the second derivative. And if the second derivative is positive, then dH dt is increasing. If the second derivative is negative, then dH dt is decreasing. But I don't know that yet, so I need to plug in. Let's see. Oh, I have an expression for dH dt. So in place of dH dt, I can put negative 1/10 square root of h. Okay, so let's see if we can figure all that out together. So that'd be a positive 1 over 200. What about h to the negative 1/2 times the square root of h? Does that cancel or does that make h? H to the negative 1/2 is 1 over the square root of h. That's just the square root of h, so they cancel. So the second derivative is 1 over 200. Always. It doesn't depend on h. Okay, so what does that mean? So the second derivative is always positive. So you said always increasing, Gabe. What is always increasing? You're right, but you got to tell me what is always increasing. The second derivative is always positive. So that means the first derivative is always increasing. What does it tell me about h while I'm here? There's what I want to say, but what does it tell me about h? If the second derivative is always positive, what does that tell me about h? If the second derivative is positive, what does that tell me about the function? Concave up. That's not what it asked, but just while I'm thinking about the different things that the second derivative tells me. So dH dt is always increasing. It doesn't matter about the 3 feet or not. At time equals 0, the height of the water is 5 feet. Use separation of variables, so it's even kind of giving you a hint on what to do, to find an expression for h in terms of t. So dH over square root of h equals negative 1/10 dt. There's my separate. I don't really want to integrate yet because I don't like this square root business. I'd rather write that as h to the negative 1/2. Then I can integrate and ask Grace and Jackson to help us. I like h to the 1/2, right? Increase the power by 1. And then divide by the new power. So just 2.
Oh, no negative.
Yeah, no negative. Jackson, how about the other side? Good. Negative 1/10 t plus c. Find an expression for h in terms of c. Okay, so I'm trying to solve for h. Let's divide by 2. When I divide by 2, Glad we're doing this one. I can't like make this one. I've got to divide by 2 because that's a t there. That's a variable. So that's negative 1/20th t. What about c over 2? That's the one that you can just kind of wave your hands and be like, it's still just c. And then let's square both sides. So negative t over 20 plus c squared. Although that's not really my final answer yet because I need to plug in 0.5. So again, they were nice. They gave me the 0 thing. So c is the square root of 5. So h equals negative t over 20 plus the square root of 5 squared. Man, that had a lot of pieces to it. That's a typical free response question where they were able to grab a whole bunch of different things. The main thing for this unit was part C, but still got to know all the other stuff. All right, let's look at number 14, a little calculator problem. Quantity R in grams of a certain radioactive substance decreases according to the exponential decay model, right there. During an experiment, a scientist determines that the rate of decay of a second substance can be represented by a linear model. Linear, so decay is, the slope is constant. If at time 0, R of 0 equals 100, t is 0, R is 100. When t is 0, S is 125. At what time will there be equal quantities of both substances? So I want to figure out when S equals R. Okay, so there's like 3 problems in one here. I've got to figure out what R is. I've got to figure out what S is, and then I need to set them equal to each other. So dr over R equals negative 0.05 dt. Separate and integrate. So Victor, how about the antiderivative of dr over R? Good. Natural log of R. Probably supposed to be absolute value, but if we're dealing with an amount of some substance, it's always going to be positive, and you don't have to worry about it. JT, how about antiderivative of negative 0.05 dt?
It's negative 0.05 t plus c.
Good. Okay. So let's do the loop-de-loop thing. So e to the negative 0.05 t plus c equals r, which means r is equal to c e to the negative 0.05 t. We're doing our algebra tricks here. Have we done enough of these for you to know what c is going to be? It's going to be 100. If I plug in 0, I'm going to get 100. So 100 in for R. I'm trying to solve for C. E to the 0. So yeah, C is 100. So R equals 100 e to the negative 0.05t. Okay, there's my r equation. Now I need to figure out the s equation. So ds equals negative 4 dt. This one's almost so easy it's complicated. So with that warning for Audrey and Thomas. Audrey, what's the antiderivative of ds? If it helps, you could put a 1 in there. It would just be s. You guys are used to doing all the hard ones. We throw an easy one at you, and it's like, wait a minute, what am I messing up here? Thomas, how about the antiderivative of negative 4 dt? Plus c, very nice. You caught it. Plus c. So let's plug in. Actually, this is another easy one to plug in. 125. C is going to need to be 125. So s equals negative 4t plus 125. Now we'll set them equal to each other. And remember that this is a calculator problem. So, you know what? I could set them equal to each other, or I could just graph them both and look and see where they intersect. I think that would be easier to deal with. So y1 is 100 e to the negative 0.05t. And E2, or is negative 4t plus 125. And I want to know where they intersect. I'm starting at time equals 0. I don't know how far to go, so let's just... Oh, my y value should have been 100 or 125, so that was a poor choice to start with. So I definitely need to be up at 125. So there's R, and then there's S. Oh, it looks like they'll intersect, but I need to look at more of the window here. So let's go out to 40 and see what we can tell. So there's R. There's S. There's their intersection. So second calc, intersection, first curve, second curve, guess. Now let's be careful. That means time is 23.548, and the amount is 30.808. Let's make sure we answer the right question. When, at what time, t, so 23.548. Goodness, what a problem. Forced us to do 2 separated integrates. I guess that was the bulk of it. And then just use the calculator to see where they intersected each other.